All right, so this week what we're doing in our support class is looking at some applications of GCF and LCM, greatest common factor and least common multiple. And in particular, what we're doing is we're taking a look at word problems where to get an answer, you have to use either the GCF or the LCM. And sometimes even finding one of those is just a step in the process of answering the question. But I want to take a look at two examples, one which is going to require us to find an LCM, another which is going to require us to find a GCF. And hopefully by going through these examples, you can get an idea of how to know when to use which of those two things to answer the question. So the first question is this: 3 bells ring at intervals of 85, 35, and 15 seconds respectively. I made a mistake here, so just ignore that. If the bells rang together at 8 o'clock, when would they ring together again? Okay, so 3 bells every 85 seconds, one of the bells will ring. Every 35 seconds, one of the other bells will ring. And every 15 seconds, the third bell will ring. And so that means they're going to be ringing at different times, but at certain times, all 3 will ring at the same time. So we know that at 8 o'clock, that's one of the times that happens. Now, how do we determine when each of these bells is going to ring? Well, one thing we could do is see how much time has elapsed from 8 o'clock between that time and each successive ringing of that bell. So for example, after 85 seconds, the first bell will ring once. And then after another 85 seconds, which 85 plus 85 is 170, that first bell will ring a second time because that would be the next 85 seconds, and so on and so forth. That list can continue on and on. The second bell will ring after 35 seconds, and then after another 35 seconds have elapsed, it will ring a second time. So that's 35 plus 35, which is 70, and this list goes on and on and on. Same thing with the third bell. It'll ring after 15 seconds, and then after another 15 seconds, which would be 30 seconds total, it'll ring again. So what it looks like we're doing is listing multiples for each of these ringings of these bells. And again, what we're looking for is the first time after 8 o'clock that all 3 of these bells will ring simultaneously. But another way of thinking of that is the first number of seconds that will appear in all 3 lists. Or the first common number of seconds, I could say it that way. So that's the same thing as finding the LCM of these 3 numbers. It's the first multiple that will appear in all 3 of these lists, even though it will appear in different places within those lists. So I could find that LCM by continuing these lists on and on and on until I find that common multiple. But as we have seen, that's the long way of doing it. It takes potentially a very long time before you get to the correct answer, and we don't want to waste time doing that. Instead, let's use our technique where we can find prime factorizations for these numbers and then get an answer from that. So 85, in fact, all of these numbers, 85, 35, and 15, are products of 2 primes. What that means is that these will break down very, very quickly. 85 is equal to 5 times 17. 35 is equal to 5 times 7. I don't know why I put the multiplication symbol in there. 15 is equal to 3 times 5. So if I were to write those out, 15 equals 3 times 5. 35 equals 5 times 7, and 85 equals 5 times 17. Remember, our technique for finding the LCM of those 3 numbers is to take the primes that show up, the highest power, I should say, of each prime that shows up anywhere amongst these 3 and multiply them out. Now, each of these primes only appears at most 1 time in each of these prime factorizations. So we're not going to be raising anything to a power higher than 1. But I do see a 3 appearing. I do see a 5. I see a 7. And I see a 17. So the LCM is going to be the product of those 4 prime numbers. This comes out to 1785. Okay, now that's not our answer right away. That's the main step in getting to an answer, because look at the way the question is worded. When would they ring together again? Well, remember, these are keeping track of seconds, right? 85, 35, and 15 seconds. So this means this would happen 1,785 seconds after 8 o'clock. But what is that? What time would that be? Well, instead of working in seconds, let's convert this to minutes. Okay, 1,785 seconds divided by 60, because there's 60 seconds in a minute, would tell us how many minutes that is. That comes out to 29.75, or 29 3/4 of a minute. So what would that be? Well, we know that it's 29 3/4 minutes after 8 o'clock, so that would be 8 o'clock, or sorry, 8:29, because it's 29 minutes, and 3/4 of a minute is 45 seconds. So that would be 45 seconds. We could write that this way: 89, 29, and 45 seconds. Hold on one second. What has it been? Yeah, just give me a couple minutes, please. Sorry about that. It's my son. All right. So this would be our final answer. And again, if you're confused about where I'm getting from getting this 45 from here, 0.75 is the same thing as 3/4, but we're talking about 3/4 of a minute. If a minute is 60 seconds, then 3/4 of that would be 45 seconds. All right, let's get this last example under our belts. So this first problem involved finding an LCM. The second problem, as you might guess, is going to involve finding a GCF, and we'll try to explain why that is. So let's read it first. Samantha wants to plant 45 sunflowers, 81 corn plants, and 63 tomato plants in my garden. If she puts the same number of plants in each row, and each row only has one type of plant, what is the greatest number of plants she can put in one row? So what we're doing is we're taking each of these groupings of plants, and we're splitting them into equally sized rows, and then laying these rows out in a garden. So you can think of that as dividing each of these numbers up into equal parts. Okay, so we want to divide 45 by something to get an equal number of parts. We want to divide 81 by something to get an equal number of parts, and 63 up into an equal number of parts, or groups, or rows, or whatever you want to call that. The trick, though, is that we have to divide each of these three numbers in such a way that the result has the same number of parts in all three cases, because those become the rows, and the problem states that we want the rows to all be the same size. So what this means is we're looking for the greatest common factor of these three numbers, because the factor would determine how many plants are in each row. Okay, so what is the GCF of these three numbers? Well, we can approach this in a similar way as what we just did. We can find GCFs using the prime factorizations of these numbers. So starting with 45, I know that 45 is equal to 5 times 9. That's prime. 9 is equal to 3 times 3. Those are prime. 81 is equal to 9 times 9, each of which is equal to 3 times 3. And then finally, 63 is equal to 7 times 9. 7 is prime. 9 is equal to 3 times 3. And so what we have here is 45 equals 3 squared times 5. 81 is equal to 3 to the 4th power. And 63 is equal to 3 squared times 7. Okay, now GCFs are different from LCMs because with the case of GCFs, we are not looking for the largest power of each prime. We're looking for the smallest power of each prime that appears. And not only that, the prime, if we're going to use any primes in our product to come up with this GCF, they have to appear in all three of these. Unlike LCMs, where they need only appear in one, at least one of those prime factorizations. So this is the GCF of 45, 81, 63. Okay, so the only prime that's appearing in all three of these prime factorizations is the number 3. We have a 5 and a 7, but neither of those are appearing in all three of them. And not only that, the smallest power that I see appearing in any of these three prime factorizations is 3 squared. So that's going to automatically become our GCF, 3 squared, which is 9. And again, it's 9 plants per row. That's what the question is asking us for. Okay, so that's just a couple of examples of application problems involving those two concepts, GCF and LCM. The assignment for this week is just a bunch of these types of problems. You have to determine whether it's the GCF or the LCM that you're looking for, and hopefully these kind of give you a sense of how to determine that.